Hey, my name is Jay Binks. I'm the Chief Technology Officer for Over the Wire, looking after our Collaborate platforms. So that's our hosted PBXs, our Tier 1 voice network, and pretty much anything that falls into that category. So I'm going to start with a little bit of a story about who we are and how we got to the Tier 1 thing. In 2008, Over the Wire started offering wide area network services and co-location to mid-sized businesses. As part of that, one of our offerings was a hosted PBX service, which was quite popular. Many of the wholesale providers at the time were less than reliable back in 2008, most definitely. One of these providers went as far as to installing backup ISDN services to try and provide a reliable service. After numerous customer impacting faults, we decided to start aggregating these services so that we could provide our customers with a more reliable service. We use this not only for our hosted PBXs, but we also started wholesaling the service. We effectively built what other carriers couldn't provide us. We built a reliable network. By aggregating multiple carriers together and automating failover, we managed to make customers not able to notice the outbound calls when they were able to drop. And we put our customers' numbers across pretty much every network we had so that they didn't have all their eggs in one basket. We frequently encountered a lot of fun with the upstream carriers. Outbound calls dropping out, outbound calls having terrible call quality, inbound calls, you call them and you'd have unallocated number. We even had private wholesale voice services from one of the big carriers that, our isolated wholesale private voice services were impacted by a DDoS because we shared a line card with them. And another one of the fun things in that space was one of the carriers decided it was a great idea to transcode calls to a really lossy, terrible sounding codec in their network because they didn't want to provision more IP bandwidth. We built our customers useful portals and customer portals and APIs. We made a point of holding inventory for phone numbers across the entire country so our customers could instantly provision phone numbers. Customers could set up new SIP users, modify their passwords, configure the routing. We offered the ability for customers to send calls to their mobile if their DSL was offline, other sites, all the normal things you'd kind of expect to be able to do. But in 2010, this was actually kind of a huge differentiator. Not anyone else in the market was providing that sort of self-service, let alone the ability to have failover on some of these things. We built near real-time call limiting and fraud protection. We saw a ton of toll fraud incidents. I'm sure everyone else has as well. And we took that as a way for us to better learn from those and to provide a better service to our customers. We did really simple things like we restricted the IP addresses to Australian IPs because most of our customers are in Australia. We limited international calls to 1 or 2 concurrent international calls at a time because, well, that's pretty much what most people want to do. We gave customers the ability to specify ACLs on their SIP trunks because, hey, businesses generally had static IPs. We did really things that I kind of thought were dumb, but they worked, like blocking a user agent because script kiddies are too lazy to change the user agent in their scripts. But that cut out 90-odd% of the stuff we were seeing. We had some rudimentary call pattern detection that could suspend international calls if anything really sus happened. So little things like that just made a huge difference. We tried to hide the ugliness in the porting process, right? We built automated systems to automatically test numbers at the completion of the port. We kind of did a full matrix of calls from every single mobile network, every single fixed network, and we'd raise faults automatically if there were problems with it. That was something that we took on as our problem, not our customers, because this thing should just work. We tried to simplify the porting process by giving carrier service providers an overarching porting agreement so they didn't have to do a different piece of payment for every single number they wanted to port. And we actively responded to feedback on our APIs and customers going, hey, it'd be really cool if we could do this. So we built our platform in open source like many people did, many people still do. We simply couldn't ignore the barrier to entry of open source. It's just too cheap. The CapEx savings when you're in a startup, it's essentially free. Our initial thought process was this will probably be good enough for us until such a time that we need to go and pay for something commercial. However, as time went on, our experience grew, and we actually became big believers in open source for something other than just the price. We started committing patches back into the source tree. We extended the functionality in places where we found we needed things. One of the best examples that I really love is our engineers started digging into the code when they were finding weird things and going, why is this happening? Oh, I can see that. And then without even having to patch things, they were able to find workarounds and go, well, if I just change this bit of config, then we can avoid that. That's all stuff you're not going to be able to really do with a commercial vendor, and to be honest, we love it. We found undocumented features and capabilities, which are likely just because open source typically has terrible documentation, but hey, that's a different point. You know, and as far as us building a business on top of open source, we made a point of giving back. You know, there was the Amazon wish list, we bought tons of stuff on that, and went to conferences, trainings, paid for support agreements we never used, just the general type of stuff. Anyway, we kind of grew to a point where we had a significant number of customers on there, and we started to reevaluate. And you know, like we probably didn't look too hard, but the reason we didn't end up really looking that hard was the scalability of this thing was just incredible. We weren't hitting problems. We didn't have a support nightmare like vendors would like us to believe you're going to have when you're using open source solutions. And I guess the underlying is there was literally no compelling reason to invest a significant amount of effort in changing it. So this is kind of the tech stack that we pretty much run on. Out the front of the actual voice service, we have Kamailio, which is a SIP proxy, which does a whole bunch of stuff for us. Load balancing, pretty much anything where you want to manipulate SIP messaging is what we do in that. FreeSWITCH acts as a SBC, so it has a call in on one side, a call out on the other side, and it's a really nice defined barrier. A bunch of code written in PHP, because hey, it was 2008, that's what you did, but hey, it's still running, and not a problem. Since then, we've started adding a bunch of Go into the mix as well. You know, MariaDB, MySQL, Memcache, pretty much everything you'd expect to do there. We use Proxmox again because we're big believers in that open source, and hey, when we could change, we once again found no compelling reason to in that space. Anyway, everyone else started building in the public cloud, and we actually decided to go on our own middle. We wanted to 100% guarantee that customer traffic had the best possible chance of quality. And to do that, we believed we needed to have predictable IOPS, we needed to have predictable packet delivery times, and we believed the simplest way to achieve this was to have our own bare metal, to have our own switching and routing infrastructure, and big fat pipes directly connected into our core network. Now, there's some workloads that are perfectly fine in virtualization, and we absolutely run containers and virtualization, but not for anything that's in the audio path. If it's in the audio path, it may as well sit on hardware. We operate our customer-facing equipment in 5 data centers currently on the east coast of Australia. Each of these pods are standalone with replicas of everything they need to switch calls, and they don't rely on a central kind of point of truth. We make a point of everything being replicated out so that survivability is a big concern for us. We operate another 10 or so carrier aggregation ranks around the country, and most of this lives in NextDC and Equinix, and in some of the western states, a few other smaller DCs. As far as the design, we avoided single points of failure, but underlying was to avoid the complexity. We did simple things like build our networks using standardized layouts. We operate dual top-of-rack layer 3 switches. Each of those are BGP meshed back into multiple 10 gig uplinks within the over-the-wire core PEs. Each host in the rack is dual connected into those with NIC bonding for failover. We have physically separate OOB networks. We have an external untrusted network. We have a VRF for our internal trusted stuff, and then each of the carriers on the upstream either have VRFs or private layer 2 segments depending on the topologies they demand. Our SIP load balancers, like simple things like we operate a floating IP on those guys, so they're totally stateless. We can flip traffic between A and B without dropping a call, without really even dropping a packet. And we actually exercise that quite regularly during our maintenance windows. It's pretty essential to us, to be honest. That's one of the biggest ones. Our customer-facing SBCs act as back-to-back user agents. Like I said, they provide the edge of that voice network, and customers can't see and pass there. These boxes terminate our RTP, our media, and they're the main method of providing us horizontally scaling. We can trivially add more boxes in there. We typically run about 3 of those in each of those pods. And funny enough, we operated about N+2, allowing heaps of headroom there. The limiting factor for us is not the hardware. The limiting factor is the size of the failure domain, and if something were to happen, how many calls we're prepared to impact. We've got a number of virtualization hosts in those racks as well. They run things like route servers, LCR, application servers for handling of inbound call routing, and little bits and pieces like that. We essentially keep our virtualization needs exceptionally simple. Again, there's no clustering at the hypervisor to avoid split brains. We don't do any shared storage on those hypervisors. All the redundancies at the application level. Once again, the KISS principle. All hardware is racked up is pretty much identical. It's dual Xeon Silver CPUs currently with 64 gig of RAM and mirrored SSDs. The only real difference we see by anything in the racks is how much RAM they have and the SSD size. And that's because the virtualization has RAM. We generally have 2 or more web-borne spares in each pod, and this gives us hardware that we can quickly scale if we need to, but more importantly, it's used during maintenance. Often it's actually quicker for us to run up a workload on one of the spares and pull one of the other ones out and do it that way rather than actually doing an in-place upgrade on some of those things. Generally in the case of the very limited, hey, a Dell server has failed, we can replace it quicker than we can get their support guys on site. So we only have to take next business day with them because we can move a workload within minutes onto another box. We remove call flow within seconds. We move the workload permanently on the box within an hour, and then next business day comes back a day later and sorts things out. We designed everything to fail and kind of work backwards from that. Like the failure modes of everything are very front of mind as we build this stuff. So we decided to prioritize customers' abilities to always make calls and for the system to essentially fail open to a reasonable degree. We'd rather that a customer be able to make the calls that they want to do than for us to build them. And we'd rather just not give a customer that outage. Now, in reality, we've never had that because of how we handle the CDRs and all the bits and pieces there. But that design is absolutely front of mind that, we'd rather prioritize those things. There is a small possibility that, like we'd allow a customer to go over predefined credit limits or something like that if they're in a maintenance window, but that's perfectly fine from our side of things. Another example of engineering around how things fail is we had the ability to do live call failover between SPCs. The platforms we use support it, it's really cool, I would love to play with it, but when you kind of take that nerdy engineer hat off and go, well, should I do this? It became a case of no, because to be able to do that, we had to have call state across the network in a centralized place. You then introduced a single point of failure, and the funny thing is customers, as long as they, when a call drops out, as long as they can pick up the phone and hit redial, generally 9 times out of 10, they go, that was weird, and they continue on their conversations. All right, so who cares? How did we become a tier 1 carrier? So a bit of a story here. At some point around 2012, I was getting even more frustrated at the upstream carrier faults we're still seeing. And because there's no equivalent of BGP in the voice world, you can't simply advertise your phone numbers on multiple carriers. You've pretty much only got static routes and you've only got a single carrier for that phone number. So I said to the team one day, and mind you, we would have had around 20 people at this point in time, stuff that we're going to build a tier 1 carrier. Because it was the only way to actually do this at scale. And look, everyone laughed, everyone kind of thought I was crazy, but honestly, that kind of solidified in my mind the direction we were heading. If we're going to be serious about that, it was the way we had to go. So I spent my weekends, my evenings reading comms alliance documents, falling asleep halfway through, figuring out how carriers are interconnected and the regulatory frameworks in place, and started bugging the guys at Telstra and Optus, who I'm sure thought I was just a nutter at that point in time, but it's what we had to do. In late 2012, we realised we could start making a start on the project with minimal expenditure. While we were still technically a CSP, we started building out our core routing and number ownership infrastructure. We reached out to the carriers, sometimes with varying levels of success, and started accessing the porting data that we needed. Hacked together a bunch of bash scripts, and we started parsing that data. And Rodney, I'm pretty sure those bash scripts are still running, aren't they? About 2016, the time came to start working on this in earnest. We started negotiating carrier interconnects with a number of the easier carriers. These are the guys that allow us to do it over SIP for a start, not TDM, and they were generally happy to let us do it in 1 or 2 capital cities rather than having to do every single CCA around the country. The intention for us at that point was that we would simply be leveraging the carrier interconnect services for outbound traffic while we left the inbound traffic on our CTS providers while we built the rest of the things we needed and, quite frankly, learned the things we needed. By the end of 2016, we'd executed carrier interconnect agreements with Optus, and we placed some orders for capacity in 2017. Now, I'm not sure if anyone had used Optus CTS CI service at that point in time. Maybe David will set me right, I'm not sure, but most definitely, every single time you'd ask the question, the answer was, I don't know, we're going to have to figure this out. Pretty much nobody knew how this stuff worked. Around 2017, Optus delivered that first interconnect service, and we quickly and excitedly commenced routing traffic over the Optus. Using exceptionally rudimentary call routing ability, probably did it all wrong, but hey, it worked for us at the time. We learned a lot, we observed the numbers routing data from other carriers, however, we still weren't 100% confident we were doing it right. See, everything in G500 and G549, which is the console line specs for interconnection, is very TDM centric. The regulatory stuff is entirely void of anything related to SIP, so we had to figure it out as we go. Some of the things like the interconnect dial plan were trivial, but other things weren't straightforward. We found weird things with Optus at the start there, like, you're on IP, so you were exposed to all the weirdness of their end IP customers, as far as codecs and super interop issues. So, in a carrier call routing, I said there's no BGP. It's pretty much a whole bunch of static routes, but it's worse than that. You can't aggregate any routes. Each number has to be routed individually, because each number can be ported individually. And the routing protocol is pretty much email and text files. So there's millions of numbers in Australia, individual numbers can be ported, and you can't aggregate it. So call routing at scale was something we had to work through, we had to figure out. And in the model we had, I didn't want centralized DB calls, I didn't want to have to do multiple DB calls to look these things up, so we had to work through it. I kind of had a brainwave on the way back in 2017 on a flight home from Chicago. There was a FreeSWITCH conference over there I was attending, and I managed to pull out the laptop, pull out my Linux VM and start coding a Kamailio module in C. The idea was essentially we'd load the entire ACMA database of every single number allocated into an in-memory structure, we'd overlay the porting data, and hey, I've got 12 to 13 hours to wait on the flight, let's see if this thing works for us. They kind of did in the end anyway, but hey, each node would store enough information to be able to tell us who a number is allocated to, if it's recently ported, and a few other elements of information. We managed to get that into an in-memory tree using about 4 gig of RAM, and the lookups for that were exceptionally fast. I was very happy and still am to this day, to be honest, it hasn't changed significantly. The routing engine makes a decision on average with a latency of just over a millisecond. We actually have caching in front of that because there are a lot of numbers that get used multiple times within an hour or within minutes. So with latency on the caching, it's around 100 to 200 microseconds. The funny thing on that is if we were to do a lookup in another one of the pods across the same city, it would actually take longer for the packet to reverse the network than we were to look it up locally. We routinely test that out to about 50,000 lookup a second, which is significantly more than we need. In fact, that number would cause all the other carriers to cry. By the end of August 2017, we had this thing in production. We had the capacity to correctly route calls to the correct carrier, observing porting data. Throughout 2017, we continued negotiating other agreements with smaller carriers, entering agreements with Symbia and Vocus around November, December of 2017. In early 2018, we leaned on the experience gained from Optus and we started sending traffic to these carriers. And at that kind of point in time, we had about 40% of our geo number traffic going over interconnect paths. This is where we started to hit a side bump. Sorry, a speed bump. And I'm sure you're all going, which carriers we're missing that he didn't talk about. So, remaining carrier AA took their sweet ass time responding to any requests. They struggled to find internal resources to fulfill these requests for interconnection, which we kind of thought was their regulatory obligation, but anyway. Remaining carrier V, with lots of letters after that, had outsourced everything to an external vendor and wanted, after months and months of meetings and trying to get something back from them, the first thing they did was say that's going to cost you $500,000 in billing validation for us to be able to send you a bill. Remaining carrier Big T had a different interpretation of the regulations to everyone else that we dealt with at that point in time. Needless to say, all of these things took significant time and effort to work through. We met with regulators, lawyers, carriers, and back and forth multiple times. 2 years later. So actually, we did get something done in that 2 years. We did manage to sign an agreement with the TPG group. But I'm going to kind of gloss over that a little bit. But somehow the clouds parted, the rain stopped, and we finally got a glimpse of the sun. Telstra had agreed to interconnect with us on terms that we could agree to. Once the agreement was reached, we started the real fun parts because we had to place capacity orders. Lots and lots of TDM. And not just TDM, copper TDM. So this is around don't have the date in my slide, but it was around 2020, 2021, so it's not that long ago. Imagine talking to the next DC going, I want hundreds and hundreds of copper pairs. Yeah, so we had to get contractors to install copper cross-connects in NextDC networks. We had to negotiate special cross-connect rates on the monthlies because they all charge per pair. We had to deal with contractors mixing up transmit and RX on the Chrome panel. All the things that you had to do in the 90s and early 2000s, you had to do it recently. We'd asked for fibre delivery to our rack. We pleaded for fibre delivery to our rack, but nada, that wasn't going to be allowed. So we went on to place the copper orders and test each individual copper pair. After installing hundreds of copper pairs, after 8 of the 10 sites were done, and in testing at the voice layer, not just the copper layer, they decided to deliver a TDM mux into our rack, and they asked for a simple cross-connect to be delivered. Kind of the thing I've been asking for the whole way. Anyway, we got there in the end. By early 2021, we had a Telstra capacity in place for production outbound calls. We quickly turned our attention to inbound traffic because the outbound was happening. We only touched on a few major milestones of the project, but before now we'd acquired our own phone numbers directly from ACMA, we'd conditioned them on everyone else's network, aka the email routing protocol. We'd had the largest, with the largest carrier, Telstra completed, we could test inbound reachability now from every number across the country. When we'd satisfied ourselves that everyone in Australia was able to call our numbers, we took the scary step of allocating these numbers to our customers. We then moved our attention to the final stages of bringing our LNP systems online. We commenced migrating numbers soon after the number porting system went live, half of the legacy carriers, and very quickly we started making them cry. Who'd have thought that in this day and age, most carriers still have people involved in every port? Now, we know Category 8, Category C ports have got people involved in them, they're project managed. But Category A ports are a single number port and meant to be fully automated. The spec from Comms Alliance is pretty much all automatable. But for some reason, pretty much everyone still has people in them, and we've got no idea why. We started doing a few hundred ports a day per carrier. We had over 500,000 numbers to move, so we thought that's pretty reasonable. It's not that many. Boy, was I wrong. Optus came crying very quickly and said they can only handle 10 ports a day. Now we've negotiated them up to 30. And pretty much the other carriers really wanted us to limit it to 50. The problem being that they'd automated the ingestion of these ports to gain numbers, but when you try and port numbers out, they still manually validate every port out request with a human. Finally, in October 2021, remaining carrier AA had managed to wrangle the teams required to build the 10 Ethernet cross-connects and 10 SIP services that constituted our network work. That was the practical completion of our Tier 1 network around October. So that's kind of the story, I guess, at a high level. I'm going to sort of move on to some of the learning, some of the WTF moments, or the ranting, as it may. Oh, lovely. And we're going to crash. Sorry, now I have to try and figure out where we're up to. Current slide, here we go. Heard it so many times. Why don't we just give you good CTS rates and you guys forget the Tier 1 thing? One of the carriers had to bring some guy back from retirement because nobody else knew how to do it, and pretty much they all just said nobody's built an internet network. Nobody's built an internet network in the last 10 years. Apart from David. So why are you doing this? Call routing. Different numbers are routed different. I explained the geo number routing and the static routes and the email-based routing. Well, 1300, 1800, you've got to pay a government-appointed monopoly to look after those for you. Mobile routing is very similar to that, but once again, you've got to kind of get your real-time mobile routing data from another monopoly. It's all different. Some of the things are regulated, others aren't, such as fixed network costs. That's all variable. Some of the carriers believe their regulations don't apply to you. It's way open to interpretation still. Some carriers simply don't care about their obligations and know your only recourse is to go to court. Our experience was that the regulators really don't want to enforce anything. So, like obviously your fixed and mobile calls are regulated, but 131-800 aren't. You've got some general consensus around the other carriers around what that looks like, but it's still not great. Commercials around porting are the real thing that doesn't operate. That's completely unregulated. The system's so entirely broken. Cat-A's are meant to be automated, like I said. Cat-C's require batching per city because Telstra, used to have a lot of exchanges and that's how they like to see it. Time zones on Cat-C ports, well, the spec says it's all meant to be done out of Sydney time, but when you ask Telstra for a next available business hours slot, they don't realise that the numbers are in Perth and their billing team will bill you that one as an out-of-hours port. So that's a real gotcha when they don't even know operationally from billing how they work within themselves. And it's contrary to what Comms Alliance says. You just got to negotiate it, not negotiate, you've got to go through it all and find your way through it. A Cat-C PNV process is ridiculous. It's manual, it's on a spreadsheet, you're paying between $75 and $350 a batch. It's time consuming, takes about 10 business days and often returned with mistakes. So after paying the money, you've still got no guarantee. If you go and submit that PNV into a CNA and have mistakes, you're up for punitive rejection charges of between $10 and $20 per number. So a batch with 1,000 numbers on it is literally $10,000 and $20,000 potentially. Out-of-hours port fees are hundreds of dollars for an out-of-hours port, and you get not a project manager, a porting administrator on it for you who can't fix anything. You've got no idea why we're even paying for these things. The real way that should be working is that you shouldn't even need out-of-hours ports because the porting system should guarantee call delivery during the process, and everyone should just be made to do it during the back. Anyway, on to some questions, if anyone's got some. And no, Andrew, I can't do it for $100 a month, mate.
We've got time for one from the floor. If we've got anybody who's got one now, or Jay's, would you have one? Of course. You couldn't move closer.
So, given what you're saying is the current state of that whole porting process in the industry, do you see any sort of light in the end of the tunnel to having, where you would take all this stuff and talk to somebody who may be able to make a difference and crash these heads together?
Comms Alliance are actually reviewing the porting stuff. This is where I'm actually really excited about the relationship and the acquisition with ABB. In our previous organisation, I was pretty much one of the only people involved in that regulatory and getting involved in the submissions to Comms Alliance and that. The team have got an exceptional compliance and risk team that actually already over some of this stuff, and I'm excited to work with them to work through that with Comms Alliance and lobby and see if we can maybe fix some of the regulatory stuff in that space.
Unfortunately, we're out of time for Jay, but yeah, it's an interesting topic, and I'm sure you're loitering around for the rest of the day.